Welcome to the session on machine drawing. In today's session, we are going to see the thread forms. In the thread forms, we are going to see the thread definition and the nomenclature of the thread or thread terminology. So first, a straight thread is a ridge of uniform section that followed the helical path on external or internal surface of a cylinder. So basically, thread is a helical form or helical ridge which will be formed on the external surface of the screw or the internal surface of the nut. So this is a figure which will demonstrate the terminology of the threads. So here you can see the different parameters. So first parameter is crest. So crest is the outermost part of the thread. So this portion of the thread is called as crest. So outermost part of the thread, okay, so this part is called the crest. Then second is the innermost part of the thread, which is nothing but the root. So this part of the thread is called as root. This part or this part is called as root. Then third part we have flank or side. So it is the surface between crest and root. So if this is a crest and this is a root, so whatever this surface is here, this surface is called as flank or side. Then the next term is thread angle. So it is the angle between the flanks measured on an axial plane. So if you have got this as a flank, this is the another flank, the angle between two flanks is called as thread angle. Then the next term is called as depth of the thread, which is denoted by capital H. So it is the distance between the crest and root measured at right angles to the axis. It is equal to the half of the difference between outside and inside diameter. So if you take this as a crest and this as a root, and if you measure the distance between crest and root, which is perpendicular to the axis, so or right angles to the axis, so that perpendicular distance between the crest and root is called as depth of the thread or height of the thread. The next one is outer or major diameter. The diameter which passes through the crest. Okay, the diameter at the crest of the thread measured at right angles to the axis of the screw is called as a major or outside diameter. And there is one more term called as core or minor diameter. That diameter will be measured at the roots of the thread. So this would be the minor diameter between this root and this root, and between this crest and this crest it will be called as a major diameter. The next part what we have got is the nominal diameter. So basically this nominal diameter is the diameter of cylindrical piece on which threads are cut. So if you have, this is the diameter of the cylinder on which threads are cut. So this diameter is called as nominal diameter. Then further, the very important term which is called as pitch, denoted by capital P, and it is the distance measured parallel to the axis between one point on one thread form and the corresponding point on the adjacent thread form. Suppose if you take this point on this thread, so same point you have to take it on the other thread. So suppose here they have shown the pitch. The distance between this point and the adjacent thread, this point is called as a pitch, and this is measured parallel to the axis. So pitch is the distance measured parallel to the axis between a point on one thread form to the same point on the corresponding thread form. So it is from crest to crest or root to root. So it can be also found out using the formula P is equal to 1 upon n. So 1 upon n, where n is the number of threads. So if you know the unit length, say 1 centimeter or 1 meter, so divided by number of threads will be giving you the pitch value. The next term is called as the lead of the thread, and it is measured as the distance parallel to the axis from one point on a thread to corresponding point on the same thread after one complete revolution. So if you have got one point here, and from this point, if this cylindrical body have one complete revolution, and if you reach to the same point on the same thread, you will be getting lead equal to pitch. Then we'll be calling them as a single thread or single start thread. But if you start from the same point and after one revolution, if you reach to this point, from this point after one revolution, if you are reaching to this point, then will be called it as a double thread or double start thread, where the lead is twice of pitch, and if it is multiples of pitch, then we call it as multiple threads. So these are the different terms related to thread we have to study. The next we have to see the types of threads. So there are 5 types of threads which are there for our study. So first one is isometric threads, both internal and external we have to study. Second one, British Standard Whitworth threads, also abbreviated as BSW threads. Third one, square threads. Fourth one, Acme threads, or they are also called as modified square threads. And fifth one is Sellers threads or standard form of USA. So first one is isometric thread, both internal and external are shown on the screen. So this thread is called as the internal isometric thread, and this is called as the external isometric thread. And when we combine them together, so if you consider this as a nut part, this as a bolt part, they will be having this type of connection. So there will be some gap remaining here, which is because of the offset provided on the crest and roots of the threads. So for internal isometric thread, we have got the offset of H8 and H/4 here. So H would be the height of the thread or depth of the thread. You will be given this value of P, and this angle 60 is fixed or the standard for the isometric thread. For isometric thread, the thread angle will be 60 degrees. So you will be given the pitch value. You have to remember this 60 degrees, and you have to get this V, and then you have to get the appropriate offset here, H/4 on this side and H/8 on this side. So on this side you have to get the external arc, here you have to get the flat surface. So if you come to the external threads, again you will be given the pitch value from here to here. You have to take the angle 60 as a standard. You have to get this V. On this side we have to get the arc which is touching to this offset line, and here we have to get the flat. So here where we are getting the curve, there we have to get the flat for the external threads. So these are the isometric threads, internal and external. The next we have got British Standard Whitworth threads or BSW threads. So here again the pitch value will be given, and you have to get the arc on both the sides. So for the isometric you have got flat one side, you have got arc one side, but here you have got the arc at crest as well as at the root, and the standard angle for BSW threads is 55 degrees. So pitch will be given 55, you have to remember, and you have to get the BSW threads. So here the depth of the thread is denoted by capital D. So this capital D is nothing but the depth of the thread. So when the pitch value is given, and when you have got this angle known as a standard, so you can get the depth of the thread, and then further you can get D/6 offset on both the sides, and you can get the arc outside of this D/6 offset line, or else you can use D is equal to 0.96 of P, or small d is equal to 0.64 of P. Any of the things can be used for the British Standard Whitworth threads. Then we have got the square threads. These threads are the simplest form of the threads, where the pitch value will be given and the depth of the thread will be half of the pitch value. So first we have to start with the 1 point from here. Half of the pitch value we can take it, we can get this line. Then we can again have the half of the pitch here, we can get this line. Again half of the pitch, half of the pitch. So total P value will be getting from this point to this point, and you can get the thread forms for the square threads. The next what we have got is the Acme threads. So Acme threads we have here. So Acme threads are nothing but the modified square threads. So here what square we had there, that has been made as a trapezium. So again here the depth of the thread will remain same as 0.5 P, and the pitch from here to it will be P value, so which will be given. But here you have to remember the angle, that is 29 degrees. So angle between two flanks of the Acme threads will be 29 degrees. So at the center, from this point to this point, you will be having the value as 0.5 P, and from there you have to take half angle here, half angle here. So 29's half on this side would be taken, and 29's half on this side would be taken. So angle between these two would be 29, and you can get the thing. So if you take this length, which will be given in the proportion 0.3707 P. So 0.3007 P you can take it, and from here to here if you get the line which will be forming the P value. Next what we have got is the seller's thread. So seller's threads are nothing but the standard form of USA threads. So here the pitch value will be given to you, and as that of the isometric thread, you will be having the angle as 60. The standard angle for seller's thread is also 60. But only thing is that for isometric we had a flat on one side, a round on other side. But for this form of threads, that is seller's threads, you will be having flat on both the sides. So here also you will be having the flat edge, here also you will be having the flat edge. And again the depth can be found out using the pitch value and the angle, or else you can have the D value which is equal to 0.86 of P, and small d value is 0.649 of P. Any one can be used here, and these thread forms can be drawn. So after this we have the different representations of the V threads, or nothing but the isometric threads. So if you have got the external V threads, you will be representing them on 2D like this. The two lines at a root diameter approximately 0.9D with thin lines. And here if you show it in the side view, so you will be having the full circle for the outer diameter, and you will be having 3/4 circle or little bit more than 3/4 circle for the thread diameters or the root diameter. Then if you take the section of this, you will be representing the section of external V threads in this way. And if you go for the internal V threads representation, that 3/4 circle will be outside and the crest circle will be inside, and the dotted line outside would be thin and inside they will be thick. So similarly, if you have the section of V threads, which will be shown in this way, and if you have got the metric threads, that is isometric thread, on the drawings they will be represented as M. With that you will be having the diameter into pitch. So M20 into 1.5 if you are having the thread form shown on the drawing. So it is metric threads of 20 mm diameter, and pitch value is 1.5. And if you have got the square threads, you will be getting this square box, or sometimes TR will be used. So TR into TR followed by diameter into pitch value will be getting. So the diameter 25 mm diameter and 2 mm pitch thread of square type will be represented by square 25 into 2. So this is about the thread forms and their representations. Thank you.